All right, let's jump right into this explainer. Today we're decoding something pretty cool. It's kind of like a secret mathematical language that's hiding right beneath the surface of the things we say literally every single day. We're looking at the logic of nested quantifiers. Now, if you've ever felt like formal logic or, advanced math looks like some completely alien script, well, you're in exactly the right place. By the end of our time together, you're going to know exactly how to read this code.
But first, I want you to consider something. Can simply swapping two symbols entirely change reality? Think about that for a second. I know, it sounds like a trick question or maybe something out of a sci-fi movie, but in the strict, ultra-precise world of mathematical logic, the order of our symbols dictates the exact nature of the universe we're describing. A tiny typo, just a casual flip of two characters, and boom, you might accidentally describe a completely absurd reality. So let's solve this logical puzzle together.
Section 1. Decoding logic symbols, the building blocks of meaning. Let's get into it.
Okay, let's start with the symbol that looks basically exactly like an upside-down capital A. In formal logic, we call this the universal quantifier. Whenever you see this upside-down A, I want your brain to immediately translate it to the words for all or every. It's an absolute. It means whatever rule we establish next, well, it applies to every single item, person, or number in the group we're talking about. Literally, no exceptions.
Now on the flip side, we have the symbol that looks like a backwards capital E. This is the existential quantifier. While our last symbol was about absolutely everyone, this one is, well, it's a lot more relaxed. When you see this backwards E, it just means there exists, or some, or maybe even at least one. It doesn't mean all of them do it, it just guarantees that we can find at least one specific example out there in the universe that fits our criteria.
Section 2. The concept of nesting, putting symbols together.
Right, so before we just start throwing these quantifiers around, they actually need something to act upon. Enter the predicate. We represent this as P of xy. You can kind of think of the predicate as the action, the verb, or the specific relationship that connects our two variables x and y together. On its own, P of xy is really just an open statement. It's a relationship just waiting to be defined. It's only when we attach our quantifiers, our upside-down A's and backwards E's, that this predicate actually comes alive and makes a specific, concrete claim about the world.
Moving on to Section 3. Why order matters. The central trap.
Take a look at the stark typographic difference we're dealing with. In the first formula, we have the universal quantifier first. For all x, there exists a y. In the second one, we just flip them. There exists a y for all x. Visually, they look almost identical, right? Your brain instantly wants to group them together and assume they're just two different ways of saying the exact same mathematical phrase. But, and this is crucial, they are absolutely not equal. No way. In fact, our source material is incredibly strict on this point. Order matters. That's a direct quote. And honestly, it's the golden rule of today's explainer. You absolutely cannot just swap an upside-down A with a backwards E and expect your predicate to survive unchanged. Reading left to right, whichever quantifier comes first completely dictates the reality of the relationship that follows it.
Section 4. Interpreting with examples. Translating the abstract.
So to do this efficiently, we're going to use a super simple logical flow. Step 1, you strictly read the first quantifier. Step 2, you read the second quantifier. And step 3, you apply both of those conditions to the predicate, the relationship at the very end. If you follow these 3 steps in order every single time, you can turn pretty much any complex symbolic formula into a highly intuitive, plain-spoken sentence.
Okay, let's actually assign some real-world values to our variables so we can test this thing out. Let's make x represent people. Let's make y represent a physical key. And our predicate, our relationship P, will be the action unlocks a door. Now we've got a highly tangible, vivid scenario, right? We're talking about people, keys, and unlocking doors. Let's see what happens when we run this exact scenario through our nested quantifiers.
Let's run these side by side. First, the formula where the for all comes first. Step 1, for every person. Step 2, there exists a key. Step 3, that unlocks a door. The translation, every person has some key, which makes total sense. I have my house key, you have your house key, we can all get into our own homes. But now, let's look at the second formula where we swapped the order. Step 1, there exists a specific key. Step 2, for every person. Step 3, that unlocks a door. Translation, there is one specific key that every single person has. I mean, think about how absolutely absurd that is. That implies there's just one magical master key floating around out there that all 8 billion people on Earth share to get inside.
So the absolutely crucial point here is this. Everyone has a key is definitively not equal to one key belongs to everyone. The first one is, a normal functioning society. The second is some bizarre fantasy world where we all share a single piece of metal. By simply swapping the order of our universal and existential quantifiers, we fundamentally altered the reality of the mathematical statement. We went from a logical truth to total absurdity, literally just by moving a symbol an inch to the left.
Which leaves us with a final, pretty fascinating question. Now that you know how to decode this secret language, now that you understand that every and some have to be strictly ordered, where else is this invisible math hiding in the sentences you use every single day? When a politician says everyone loves a certain policy, or a marketer tells you there is a product for everyone, what nested logic are they actually using? Are they promising you your own key, or are they trying to sell you the master key? Keep an eye out for these quantifiers in the wild, folks, because as we've seen today, order truly does matter. Thanks so much for joining me on this explainer, and I'll catch you next time.